All right, this is polar graphing questions 6 through 10. The video cut off at 15 minutes right before I got to the end. We should have ended up getting 4 root 2 of 45 degrees. So r equals 4 root 2, and we knew it was going to be at 45 degrees on there. The other one could have been the negative direction. So if you go to negative 4 and then rotate 90, 180, 225 would get you. So negative 4, 225 is where the other answer came from. All right, so now let's get started on questions 6 through 10. It says find an equation equivalent to r equals 10 sine theta in rectangular coordinates. So to do this one, we're going to have to figure out how we're going to use these equations to be able to get some rectangular coordinates in terms of x and y. So right now there aren't any x's and y's, but if we had something like this, we could replace it with an x. If we had something like this, we could replace it with a y. So let's start by multiplying. Well, looking at this is very close, I guess. Before we jump into anything, if I look at this right here, r sine theta, that's very close to this. The only thing that's missing is an r. And if I happen to multiply both sides by r, then r times r gives me r squared over here, and I multiply an r. You can put it in front or behind the 10, doesn't really matter. You get 10 times r times sine theta. We now have an r squared, and we also have an r sine theta. So r squared equals 10 y. We can replace r sine theta with y. From here, I need something to replace an r, and while this has an r by itself, and you're like, oh, okay, I'll just plug that in there, I see the other side, what we're plugging it into, will very easily cancel out when we square the square root. So if I was to plug in right here, for r, square root of x squared plus y squared, from here, whoops, I guess it's supposed to be squared because it's supposed to be r squared on there. Let me make this a little bit neater here. The square root and the square cancel out, so you get x squared plus y squared equals 10y, and it should just be one of the answer choices there because we don't necessarily have to solve for y. So yeah, we have answer choice D is what we should have ended up with on this one. All right. Next question, number 7. Says which is the graph of r equals 4 sine theta. So there's a long way to do this one and an easy way to do this one. If you have r equals some number sine theta or cosine theta, it's going to be a circle with that diameter. So both of these are circles with a diameter of 4. One is along the x-axis and one of them is along the y-axis. Hopefully, one of the very first things that you learned about sine and cosine is that sine is representing the y value on like the unit circle, and x is how you get the cosine is how you get the x values. And notice right here, this is a sine equation, which tells me this should be the vertical diameter of this one. Not diameter, but this should be a vertical movement of this. So the answer is B on this one without actually even having to do any work. Because if you wanted to get the equation of this circle the long way, we know it's going to be x minus 0 squared plus y minus 2 squared equals the radius is also 2, so 2 squared. It takes a lot more work to get from this equation here to this equation. I'll do that at the end of the video if we have time, but the short way is just know that any equations of circles on polar graphs in this form, r equals, 2 cosine theta or 10 sine theta. Sine is going to be vertical, cosine is going to be horizontal. If it was a negative, like let's say r equals negative 3 cosine theta, that's just going to go on the x-axis in the negative direction out to 3 units. That's the diameter out there. If you wanted to do r equals negative 4 sine theta, that's going to be, that's going to be a graph that goes vertical negative 4 from the origin as well. So sine and cosine really quickly in these forms just mean the sine it's going to be a circle that's centered around the y-axis, cosine centered around the x-axis, and the number in front is the diameter away from the origin. All right, number 8 says find an equation equivalent to y equals x in polar coordinates. This one actually is really easy to do by just replacing right here. We know how to replace y with r sine theta and x with r cosine theta. So y equals x. Let's replace y here first. So r sine theta. And then next we'll replace x with r cosine theta. The r's cancel out and you get sine of theta equals cosine of theta. So answer choice A should be this one. Not a whole lot of work to do on that one. Some people probably overthought that one because it was pretty easy. All right, number 9, find an equation equivalent to x, y equals 1 in polar coordinates. We can do the same thing we just did on the last one. Just replace x and y with these two equations, r cosine theta and y equals r sine theta. So x times y equals 1. Let's go ahead and plug in for x, r cosine of theta. And let's plug in for y, r sine theta equals 1. And is that an option or no yet? No? Well, let's factor, I guess we can multiply the r's. So at this point, I do see that this answer is very close to looking like this answer here, but not quite. What's different about it is there's a 2, and obviously if I multiplied by 2 here to make this part correct, then I would have to multiply by 2 over here, and I wouldn't have that over there. But if I do multiply by 2, I'm going to put it actually r squared times 2. I'm going to put it like this. We actually get what's called a double angle identity. Now, this is what we were about to cover after spring break, double angle and half angle identities. But there is an identity that says sine of 2 theta equals 2 sine theta cosine theta. So this part right here can actually be replaced with just sine of 2 theta. So we get r squared, plug this part in right here, so sine of 2 theta equals 2. So we actually get answer choice B if we use a double angle identity. Now, I think there might be a quiz question where you need to use a double angle or a half angle identity. there's 3 double angle identities and 6 half angle identities. I would say just maybe write down the double angle identities. You might need to use one for one of your quiz questions. Just basically, if you get stuck and you're like, I have no idea what to do, you may realize like, oh, that looks very close to this double angle identity. I'll just replace it with something a little bit easier. All right, last question is number 10. It says find an equation equivalent to r equals 6 secant of theta in rectangular coordinates. Okay, so this one looks like we're just going to convert it to rectangular coordinates. If you took r, you could convert that now. Probably not going to help you as much, but we'll see what we need to do on this one. I think this was one of the practice problems. There might be a couple of different ways to do this one. Let's see. Equals 6 secant of theta. Now I'm going to go ahead and write secant as 1 over cosine. And that way I should be able to multiply both sides by cosine and get something that I can replace pretty easily. So if I multiply both sides by cosine, don't know what's happening. I get r cosine of theta equals 6, and r cosine theta can very easily be replaced with x. So that's just going to be a vertical line at x equals 6. Oh, that one was actually really easy. Straight vertical line. Yeah, should be answer choice C on there. All right. Looks like we do have some time to go back and look at question number, what was it, 7? Yeah, it was number 7. Let's talk about how we can actually convert this one into rectangular coordinates. All right, so let's say here that we have r equals 4 sine theta. And I just want to start plugging in some pieces. Okay, let's say r, I could plug in there, or I could, this looks very similar right now to this. All I need is an r, and then I could replace it with y. So if I multiplied both sides by r, I get an r squared equals 4r sine theta. And now that I have r sine theta, I can replace that with y. And from here, I have r that I can replace with this and then square it. So square and square root cancel out. Right here, if I look at these values with y, I could actually complete this square and add 4 to both sides. And I'll have my equation. So if I add 4 at the end of this, let's continue this right here. Now I have completed that square, so I have y minus 2, and obviously I added 4 to the left side, so I had to add it to the right side. I get x squared.